Introduction to E. So E is an irrational number just like pi, and it's approximately 2.718281828 and so forth forever and ever. But why this number in particular? And to figure out why this number in particular, we're actually going to look at f of x equals to 2 to the power of x. And we want to find the derivative of this, but we don't know how to find the derivative of this, so we're going to do it by first principles. So to do this, we need the f of x plus h. So wherever we see x, we just substitute x for x plus h, so we just get 2 to the power of x plus h. And first principles is the limit as h approaches 0 of the f of x plus h minus the f of x over h. So let's sub in what we've got so far. So we get the f of x plus h, which is 2 to the power of x plus h, minus our f of x, which is 2 to the x, over h. So we can rewrite our 2 to the x plus h as 2 to the x multiplied by 2 to the h, minus 2 to the power of x over h. I can now factorize out our 2 to the power of x. So we get 2 to the power of h minus 1 over h. And what we can do here is that we have the limit as h approaches 0, where we're treating h as a variable. So 2 to the power of x, well, doesn't depend on h at all, so that can come outside the limit. So we get 2 to the power of x outside as the limit as h approaches 0 of 2 to the power of h minus 1 all over h. Now, here it's quite difficult to evaluate this limit, but what we can do is we can actually sub in some small values for h and see what's going on. So we're going to use h equals 0.001, and we're going to sub that in. So that's going to leave us with 2 to the power of x. Now when we sub in h is 0.001, we get 2 to the power of 0.001 minus 1 over 0.001. And that's going to give us approximately 0.693387 multiplied by our 2 to the power of x. So what happened here? This gives us our derivative. So what happened is our original function of 2 to the power of x gave us 2 to the power of x multiplied by some number. So 0.693387 approximately, when h was very, very small. If we do the same thing for f of x equals 3 to the power of x, we're not going to run through the whole process, but if you did the same thing, you'd find that the derivative was equal to approximately 1.099216 multiplied by 3 to the power of x. So let's just write a little summary that when we had 2 to the power of x, our derivative was 0.69 times 2 to the power of x. And when we had 3 to the x, our derivative was 1.1 times 3 to the power of x. So this is a number that's slightly less than 1, and this is a number that's slightly bigger than 1. So somewhere in the middle of these two, we're going to get a special number where, and that's what we'll use as e. We're going to get e to the x, where it's going to equal 1 times that special number to the power of x. And that's why e is roughly 2.7, because it's in the middle of 2 and 3, and that's where we get our function to the power of x, and the derivative is the function itself. So a little quick summary, that if you have a function of x equaling e to the power of x, the derivative of that function is just going to be e to the x.